Greetings and welcome back. Today I'm going to be showing you the Claisen condensation, which is similar to the Aldol condensation, except that this one isn't a condensation really at all. But instead of teaching you how this works, I'm just going to ask you to try to figure it out on your own. In general, the Claisen condensation starts off with an ester and a base. I'm going to use ethoxide so that it doesn't do any trans-esterification, but I'm going to draw two molecules of this. So, if you watched the Aldol condensation already and saw how it worked, I'd like you to see if you can figure out how the Claisen condensation works. Take your time, create a nucleophile, attack an electrophile, and see what product you get. Alright, welcome back. I hope that went well. I'm going to work through this really quickly to show you how this goes. So we have right here an alpha spot, which is directly next to a carbonyl, and then can therefore have a hydrogen be removed. It's the only alpha spot I have, therefore this O- can remove that hydrogen and create an enolate, kind of, or an O- right next to a carbonyl. That's definitely going to be your nucleophile. But when we attack this electrophile, this is an ester. So instead of just going up to the O, it can slingshot back down and kick off that oxygen. This would create a new bond, but we're going to be very careful to try to get all of these carbons in. So I'm going to draw first our nucleophile, which was right here. And this carbon, which I'll label in green, just as one spot in green, was our nucleophile. That one is now bound to the carbon right here in yellow that was our electrophile. So let's draw that. So I now have a single bond to this carbon right here. And that carbon, it has a carbonyl that's been regenerated. And all of this chunk right here is gone, so that yellow carbon from the carbonyl still has these three carbons attached. 1, 2, 3. So the chunk that was completely my nucleophile is still found in the product, and the chunk that was my electrophile, minus the leaving group, is also found in my product. And that's how the Claisen condensation works. For the sake of correctness and completeness, this is what I would have expected you to possibly figure out. If you didn't, don't sweat it. It's not a huge deal. But this isn't actually where the Claisen condensation ends. You might notice that right here we have an alpha carbon that is alpha to two different carbons. So that carbon, like we've seen before, is extremely acidic. So while all of the steps that we've done so far are actually reversible, there is one more step that happens, which is that this ethoxide still hanging around pulls that hydrogen off of that spot. And the final product of that reaction, as I gave it to you, would actually be this right there. So it actually stops with a C-. And because of the fact that this C- is stabilized through resonance, this step right here is irreversible. And so the Claisen condensation ends with a C-. This step is not reversible, so therefore this reaction stops at this point. In order to get it to that actual product that we drew a second ago, that's where the second step comes in. You need to actually put this into acid in a second step in order to push it back to that product as we drew it. So the the Claisen condensation starts with an ester and a base. They get together, make a nucleophile, which attacks the electrophile, attacks the second molecule of it, and then you lose that hydrogen from the beta spot. That's actually where the reaction stops. And then you have to add some acid to push it back to where you were kind of most of the way through. All right, so that's the Claisen condensation. So I'm going to give you one example of this I'd like you to try. Any questions you have, please bring to class. Thank you very much, and I will see you soon.